Okay, this is the second part of 1.5. In the previous part we solved some linear equations. Now we're still going to be solving linear equations, but we're going to have to put the linear equations together ourselves from information that's given to us in a little paragraph. In other words, word problems. I know you all like word problems, so let's try to solve some of them. Think of them as exercise for your brain, because that's kind of what they are. All right. Um, Before we get into these word problems, we're gonna need some formulas, some ideas here. There might be, so for instance, one of the formulas, ideas that we're gonna need is that distance equals rate times time. You might have heard this as like distance equals speed times time. So for instance, if I'm traveling constantly at 30 miles per hour, how much distance will I have covered in 2 hours? Well, 30 times 2, that's 60 miles. So distance equals rate times time, that's important for us. Another little formula, an idea that's important for us is simple interest. So the interest, I, equals P. So here, let me kind of mention. So we said that here we were saying distance equals rate times time. That's this one. This one right here is simple interest. And so P stands for principal. R is going to be the rate, and it's usually in decimal form. And T is time, usually in years. So keep this one in mind. We're going to need this one as well. Perimeters, how to find the perimeter of a shape. Remember, the perimeter is the length of sort of like the outer wire that makes up a polygon or a shape. So how do you find the perimeter of a square? How do you find the perimeter of a rectangle, of a triangle? Another thing that you might want to keep in mind is the sum of the interior angles of a square. So for instance, the sum of the interior angles of a triangle, there are 3 interior angles in a triangle. Oops, I don't know how to spell. The sum here is 180 degrees. For a square, the sum of the interior angles is 360 degrees. If you were dealing with a shape with 5 sides, like a polygon, the sum would be what? What would the sum be? So 180, 360, maybe something like 520, and so on and so forth. Okay, so let's get into these examples then. Let's get into the first one here. Okay, so there's maybe a little bit of information that's not necessary in this first one. That's okay. So they told us that in December 2009, some solar energy farm was completed at the Denver International Airport. 9,200 rectangular solar panels were installed. This business is just information given to us. We don't care about 9,200. We don't care about December 2009. The actual question is down here. A solar panel or photovoltaic panel converts sunlight into electricity. Okay. The length of a panel is 13.6 inches less than twice the width. And the perimeter of the photovoltaic panel is 207.4 inches. We're supposed to find the length and the width of the panel. So pause the video. Try to see if you can come up with the answer here on your own. And then watch the video to see the process that I go through to find my own solution. But definitely give yourself the opportunity to be challenged here. Try the problem on your own. Okay, so hopefully you already kind of played around with this on your own and either have an answer or are maybe stuck somewhere in between there. Let's see if we can, let me show you what I'm going to do here. Alright, so let's see. I have some photovoltaic cell, which is a rectangle. I have what's called a length and I have what's called a width. That's what I know so far. I mean, that's what I'm dealing with. It's supposed to be some sort of little rectangular panel, and it has a length and it has a width. Perfect. The length of the panel, so this sentence right here, the length of a panel is 13.6 inches less than twice the width. That's going to give me an equation. It's some equation that involves L and W. And so then the length of the panel is, well, that's saying this. L is equal to 13.6 inches less than twice the width. You got to be careful here. That second part of the statement means in an, I guess with symbols would be written like this: twice the width minus 13.6. Hopefully we agree on that. Think about this. So the length is 13.6 inches less than twice the width. That's what this is saying right here. The length is 13.6 inches smaller than twice the width, or 2w less than 13.6. So we need that's an important little equation there. Now they also gave us another little part here. They also tell us that the perimeter is 207.4 inches. How do I find the perimeter of a rectangle? Well, the perimeter is the sum of all of the dimensions. So I have two lengths and two widths. So my perimeter, which in this case of perimeter, in this particular case is 207.4, and it's equal to 2L plus 2W. So hopefully we agree on that statement about perimeter. Now I have these two equations. Both of them involve the variables L and W. I have this other equation, 207.4 equals 2L plus 2W. I need to somehow combine these two equations into just one equation that either only has L's or only has W's. Because right now it's kind of difficult to solve for either L or W because I don't know one and I don't know the other. So what are we going to do here? So what I'm going to do is I am going to substitute something. So I'm gonna begin with this equation. So I have 207.4 equals 2L plus 2W. Okay, perfect. I mean, that's just the equation that deals with perimeter. And if you notice, the top equation says that L equals 2W minus 13.6. So right here, I'm gonna replace this L right here. Oh, sorry, my computer's being dumb. So I want to replace this little L right here with, sorry about that, there's a little delay on my computer, there always is, and so then anytime I try to erase or something, it takes a second for it to do it. So let's see if we can continue here. Alright, let's see. So we said we had 207.4 2L plus 2W. Oh geez, 2W. And right now we said we were going to replace that L right there with 2W minus 13.6 because that's what L is equal to. So then my equation looks like this. 207.4 equals 2 times 2W minus 13.6 plus 2W. So that's called a substitution. I substituted L for this other equivalent expression of it, 2W minus 13.6. Okay, And now this is good. This is good for me because now this equation down here, this equation only has W's. It only has W's. It doesn't have L and W. So now it's easy to solve for W. Let's solve for W. Okay. So what I'm going to do then is I'm going to distribute this 2 and collect like terms. So then I have 207.4 is equal to 4W minus 2 times 13.7, that's 27.2, plus 2W. Okay, so that becomes, let's see, 2W, so now collect like terms, 4W plus 2W, that's going to be 6W, and I am going to add 27.2 to both sides. Okay, so that gives me what, 234, so I'm using my calculator right now, 234.6 equals 6W. Divide everything by 6 or multiply by 1/6, and we get that W equals about 39.1. That's my W. I guess we're dealing with inches. We're dealing with inches here, so let me put the units here. Not that it's... Alright, so 39.1 is the width. Now, how do I find the length? Okay, so to find the length, I could just use this equation up here. I could use this little top equation up here that says that L equals 2W minus 13.6. I'll replace W with 39.1 now. Alright, so let me do it over here, sort of. So we're gonna say that L is equal to 2 times 39.1 minus 13.6. And if you punch that into your calculator, I end up with 64.6 inches. So that's the length of my photovoltaic cell, and this is the width of it. Alright, so hopefully you were successful on your own at attempting this problem, or you sort of figured out how, at least you tried something. Definitely pause the videos and try the problems on your own. Okay, next exercise. We're dealing with some airplane. It travels at 550 miles per hour in still air. So that just means without any other forces affecting it. This plane encounters a 20 mile per hour headwind. So if it encounters a 20 mile per hour headwind, it means that it's not going as fast as 550 mile per hour anymore. It's going a little bit slower. How long will it take this plane to travel 1,802 miles? Pause the video. See if you can answer it on your own. Alright, so hopefully you got an answer, or you got stuck somewhere, but definitely you tried something here. The formula that we're going to be dealing with here is this thing. Distance equals rate times time. Yeah? So let's see. I have airplane rate. I guess right now is 550. But then I have the wind. Actually a headwind. The headwind is 20 miles per hour. So that's slowing down my plane. So then that means that the R that I'm going to be using for this problem, so the rate of the plane is going to be 550 minus 20. or 530. So let's, so I mean that makes sense hopefully. The plane can travel at 550 miles per hour, but because of the headwind, it goes a little bit slower. It goes at 530 miles per hour. Okay, and now let's think about this little formula up here. We want the distance, so the distance covered should be 1,802 miles. So my D is going to be 1,102 miles. And this is equal to the rate, which is 530, times some time. And this is what we're interested in. This is the time. So the question is how long? How long will it take the plane to travel 1,802 miles? Well, that's what we're after, the time. Okay, well, now that we have this set up, it's easy to solve for the time. All we have to do is divide by 530. And if we do that, we should end up with 3.4 as my time. And originally we started, the rates are being measured in miles per hour. So the unit of time there is hours. So this is referring to hours. And that is my answer. 3.4 hours. This plane is going to take 3.4 hours to travel 1,802 miles, given that there's a 20 mile per hour headwind going against it. Okay, so hopefully you either got that or at least now know how to proceed in this problem. Next exercise. This exercise is a little tricky. This exercise is just a little tricky, but I think you can take care of it. Let's see. We'll discover. Yeah. So we have that a truck enters the highway. It's going 60 miles an hour. Okay, perfect. A car enters the highway at the same place 14 minutes later and drives 70 miles per hour in the same direction as the truck. So the car is going a little 10 miles per hour faster than the truck. From the time that the car enters the highway, how long, and we need our answer in minutes, will it take the car to pass the truck? This is a tricky little problem. Pause the video, see if you're up to the challenge. It's an interesting little challenge, I'd say of all of these problems, perhaps this one is the more challenging one, but you'll be the judge. Alright, so I hope that you definitely try this problem, because these types of problems are definitely tricky, and it takes some practice, and well, what better time to practice than right now? So again, we're going to be thinking about our formula is distance equals rate times time. So we have to use that. The thing though is that there are two vehicles involved. There is the truck, so the truck has a distance, a rate, and a time, and then there's the car. The car has a distance, a rate, and a time. So let's, and another thing that's sort of important here is that our answers should be in minutes. Yeah. So let me begin by talking about the truck rate. Alright, so they told us that the truck rate was 60 miles per 1 hour. And the issue here, well, that's the truck rate, and well, let me also write down the car rate. Car rate says 70 miles per 1 hour. Okay. Yeah, so those are our rates. There are different rates for each vehicle. Right now, since my final answer should be in minutes, what I'm going to do is I'm going to translate these rates from miles per hour to miles per minute. So I'm going to translate to miles over minute. And that's what I'm going to do for both of them. Okay. So in order to transform to miles per minute, I want to get rid of the hours down here. Okay, so I'm gonna introduce kind of like a translator. I'm gonna say that 1 hour is 60 minutes, and I'm gonna multiply by my rate. All right, and so then this cancels with that. So 60 over 60, that just ends up being 1 mile over 1 minute. So hopefully you agree with that. And the reason why I'm doing this is because my final answer should be all in minutes. I'm going to do the same thing for the car rate. I'm going to multiply by 1 hour over 60 minutes. The 1 hour cancels, and I end up with 70 over 60. But if I simplify that further, that would be 7 over 6. 7 miles, 7/6 of a mile every minute. Okay, so now I'm going to organize my information even further. So I'm going to say here truck. Oops. I'm going to say car. I'm going to make a little table here that's going to help me organize everything here. I'm going to have the rate. I'm going to have the time. I'm going to have the distance for the two vehicles. And everything now is sort of in minutes. Okay, so let's see. The rate is, in this case, it's going to be one mile per minute for the truck. And we said that it's 7/6 miles per minute for the car. Okay, both of them are going to travel the same distance. Both of them are going to travel the same distance. How do we know that? Well, because we're interested in the point at which the car is passing the truck. So that means that they have covered the same distance. Yeah, that's why they're exactly at the moment where one is passing the other. So hopefully you agree that for both cases, the distance should be the same. Why? Because again, we are interested in the moment in time at which the car passes the truck. Well, that means that they have traveled the exact same distance at that moment. And now the time gets a little bit tricky here. One way that we can set this up, and there's another way, but I'll just show you this one, is that the car will have traveled, let's say, an X amount of time. That's what we're interested. So how long does it take the car to pass the truck? I don't know. I have no idea. I'm gonna call it X. So that's my question right now. How long does it take for the distance that the car traveled to be equal to the distance that the truck traveled? That's another way of saying the same thing. Okay, well, if this time is X, and remember, the car entered the highway 14 minutes later than the truck. Yeah, so then this guy over here, so if this is X, then this up here should be X minus 14. Okay, so hopefully this makes sense. And now, what I'm gonna do, well, I'm gonna just use my little formula up here that distance equals rate times time. And so then this says that distance equals the rate 1 times X minus 14. And this here says that D equals, the distance equals the rate 7/6 times X. And so then I can, since D is equal to this, D is equal to this other thing, so since it's the same, D equals D, I should be able to set, so I should be able to do this. 1 times X minus 14 equals 7/6 X. And now I have a little equation that it's dealing with the time that it takes for this car to pass the truck, and I just gotta solve for it. So let's solve for it. So I guess I could distribute this 1. Distributing 1 is easy. That just says x minus 14 equals 7 6x. Okay? And then there's a couple of ways of going about this. I could put all of my x's on either side of the equation, so solve for x at this point. Solve for x. So I guess I'll solve for x. So let me subtract x minus x. So I have that negative 14. Negative 14 is going to be equal to what? 7 6x minus x. Okay, so let's see. Hang on here. Maybe let's not take this approach. Let's see. I mean, although this should work, but I'm just noticing something that might be a little bit easier here. One thing that we could possibly do here is multiply both sides by 6. So I'm gonna multiply by 6, and I'm gonna multiply by 6. What does that do? It gets rid of fractions. So then this becomes 6x minus, and then 6 times 14. 6 times 14 is 84, so minus 84 equals x. Sorry, not x, 7x. And so then, now it's just a matter of solving for x. So let's see, how do we solve for x here? What we could do is subtract 6x minus 6x. And so then that would say negative 84 is equal to x. That's kind of strange. Why do we get a negative here? Something's not quite right. Something is not quite right here. Let's see if we can figure it out. Sorry, I should have worked out this problem earlier. I thought that I could just do it in my head, but now I'm dealing with a situation here where I have slightly... This is correct. So the first part is correct. We should have translated everything to miles per minute. That's good. I think here our organization, let's see. Should this be x? So if this is the time at which the car entered the highway, x, well then the time that the truck entered the highway should be 14 minutes more. What if we change things to positive? So I think that might be what the issue is here. What if we change this to a plus? So if this becomes a plus and a plus, and so then this becomes plus, good, then that will give us what we want. Sorry, so yeah, right here there was an issue. I put a minus here, but let's think about that again. So if this is the time at which the car enters the highway, well then that means that the truck has been traveling for 14 minutes extra on top of that, because the truck entered the highway 14 minutes earlier. So this should be x plus 14 right here. And then the rest of the problem is the same, and so then my x is equal to 84. So 84 minutes. Come on. Sorry, my computer sometimes does not cooperate. And also I need to... So that's our answer here. It's 84 minutes. I just want to write minutes. Alright. Sorry about that. So hopefully, I mean, I know that this is probably the trickiest problem, and I might have just made it a little bit trickier, but think about this problem. Try to go over it again. See if you can dissect it on your own and sort of digest it and understand it better. Okay, so for the sake of time, let me move on, because we still have some more exercises to do here. All right, next one. John borrowed money from his father at 5% simple interest to help pay for college tuition. At the end of 1 year, he owed a total of $1,365 in principal and interest. So how much did he borrow from his dad? And right now what we're going to have to make use of is this little formula. Yeah? All right, so let's see. The total amount that he has is equal to the principal. The principal, or yeah, or the amount borrowed, I guess we could say. Well, let's just call it principal because that's what it is. So the total amount, the 1,365 is going to be equal to the principal. The principal is the amount borrowed. You can think about it like that. Plus any interest. Yeah? And we have a little formula for the interest over here. The interest equals the principal times rate times time. Yeah? So I guess we could say the following then. That 1,365 is equal to P, the principal that originally was borrowed, plus the interest. And the interest is PRT. And now they told us that the rate RR is 5%. We gotta express that as a decimal though. And we also know that the time is just 1 year. So my T is equal to 1. So then I have this 1,365 equals P plus P times 0.05. And let me remind you here, if you have 5%, in order to change it to a decimal, you gotta think about moving the decimal twice to the left. So 0.05. So 0.05 times 1. Alright, so then that becomes 1,365 equals P plus 0.05P. And that would say 1,365 is equal to, and then these are like terms. Imagine here, technically there's like a 1 right there. So it's like saying 1 plus 0.05. So that becomes 1.05p. Let me divide 1.05. 1,365 divided by 1.05. I'm using my calculator right now, and I get $1,300. That's how much John borrowed from his dad. Now, will he pay his dad? Who knows? That's another question. Who knows about that? Okay, so hopefully that's okay. Hopefully you have a good understanding of this problem here. Let's try the last one. The last one is a little bit tricky too, because now we're dealing with two principles. Alright, so again, we're gonna definitely be using our simple interest formula. We're gonna be using our simple interest formula, and we're gonna, well, let's see. So Jared's 2 student loans total $12,000. So Jared has 2 student loans. So he borrowed monies from 2 sources. One loan is at 5% simple interest, and the other one is at 8% simple interest. And after 1 year, Jared owes $750 just in interest. So then how much money did he borrow from each one of the sources? Try to pause the video, see if you can answer this on your own. Alright, so right now the thing to realize is that there are 2 principles. So he borrowed money from two sources. That's why there are two principals. So I'm going to say something like P plus something else is equal to 12,000. I hope that makes sense. So he borrowed money from something plus something else, and that's equal to 12,000. So now, I mean, I could call them P1 and P2, but then I'm going to end up with two variables, and I don't want to end up with two variables. Instead, kind of what I want to do is just use the same variable P. So then look, then I'm going to say here that the thing that I do not know is just going to be 12,000 minus P. Does that make sense? So then he borrowed two amounts of money. One of them was P amount, I don't know, so some amount. And the other one was 12,000 minus that amount. And together they add up to 12,000. All right. So first we gotta kind of think about that and realize that. And now he says that after 1 year, Jared owes 750 in just interest. All right. So then that's the interest from, so P R T, and then plus I'm gonna have to do the other principal, 12,000 minus P R T. So think about this little equation that I just wrote down. So remember our interest equation says that it's the principal times rate times time. Well, right now we have this interest plus this other interest, because there are two principals. So let's see. Now I think we can solve for, well, let's replace R. So one of them, let's see, this one right here, this principal, I'm going to assume that it's the one that's 5%. This other principal, I'm going to assume that it's at 8%, and our T is 1 in both cases. So I'm going to say this, 750, this is P, and this is 0.051 plus 12,000 minus P, 0.081. Okay, so that becomes 750 equals 0.05 P plus 12,000 minus P times 0.08. Now I'm going to distribute this 0.08. I got to distribute this 0.08. So then this becomes 750 equals 0.05 P plus, now 0.08 times 12,000, 12,000 times 0.08, I get 960 minus 0.08 P. So let me collect like terms, and so I'm going to do also minus 960. So that's negative 210, and that's equal to negative 0.03 P. So divide everything by negative 0.03, divide everything by negative 0.03, and we end up with one of the principles is supposed to be 7,000. Yeah, this is at 5%. And now the other principle, because so this is one of the loans. One loan was 7,000. The other loan should be 5,000, so that they add up to 12,000. So then he borrowed 5,000 at 8%. Okay, so that's it for this section. These word problems are definitely tricky and require some practice. So practice them. You know, hopefully your homework will give you also the opportunity to practice them. And I'll see you in the next video. I'll see you in the next section, 1.6. Thank you.